In this lesson, we shall focus on Math 142, that is MATH 142, vector algebra, limits, derivatives, integrals, and a lot more. We shall begin by looking at questions on vector algebra. We have the opportunity to discuss most of the most examinable questions, but as a matter of fact, there's much more than this on vector algebra that we're here to discuss, and we proceed. Right, we're focusing on WTW158 worksheet 11 on vector algebra. Now, we were given in the first question that the vector A is 2, 2, and 0. The vector B has the components -1, 1, and 0. The vector C has the components 0, 1, and 1. Explain why vector A and vector B form two sides of a right-angled triangle. Okay, so we need to explain why vector A and vector B form two sides of a right-angled triangle. And once the examiner makes mention of the fact that we have a right-angled angled triangle, it means therefore the two vectors A and B form an angle of 90 degrees, and therefore it means that we have what you call orthogonal vectors, like so. Now, what do we then say? We attempt therefore to find the actual vector dot product, meaning the vector dot product of A and B is 2, 2, 0, dot, -1, 1, and 0, like so. We compute the vector dot product. Component-wise multiplication means the first component is multiplied by the first component. Similarly, the second component is multiplied by the second component. In other words, the second component of the first vector is multiplied by the second component of the second vector. The third component of the first vector is multiplied by the third component of the second vector, meaning with A dot with vector A dot vector B, and the result is -2 plus 2 together with 0, and that means with vector A, vector B, which equals 0, like so. And we are thrilled, therefore, to then say, we're to explain why A and B form two sides of a right-angled triangle. It is clear that the vector dot product of A and B is 0, and that implies that, therefore, vector A is actually orthogonal to the vector B. Any question on this one? And obviously, I'm sure there are many ways to do this one, and this is just one way to do the question, and obviously the most popular. Any comment there, Atlahong? Any question? No question. Thank you. We move forward. Right, in 1.2, we're interested in finding something, right, in actually finding the angle between B and C. Right, the vector B has the components -1, 1, and 0. Simultaneously, the vector C has the components 0, 1, and 1, like so. Now, with this mentioned, we have the chance, but we are planning to actually find the actual angle between the two vectors B and C, right? So now we need to remember something about this. So if we need to find the actual vectors between B and C, we know very well that we must be in a position to find the actual angle between the two vectors. Now, if we do that, we need to be able to remember the formula, right? So, right. So now we need to be able to remember the formula for finding the angle between two vectors, right? So now, what then do we do here? We need to remember the cosine formula, right? So there's something called the cosine of theta. And the cosine of theta would be the vector B dot the vector C, right, divided by the length of the vector B times the length of the vector C, like so, right? And now these will allow us to find the angle between the two vectors, so that we have the cosine theta equals the vector B, which is minus 1, 1, 0, the vector C, which is 0, 1, 1, and we actually are dividing by the vector B, which is the length of this here, right? And then we have the C, which is 0, 1, 1, like so, right? And what is then that we're getting out of this, right? We're able to therefore make the observation that at this point, we can be able to find the answer, meaning cosine theta equals, let's look at the dot product here, because we want to find the angle between B and C. Now, here, multiplying the first component by the first component gives us 0. The first component by the first component gives us a 1. The third component by the third component. So we have multiplied respective the first component with the first, the second component with the second, the third component with the third component, giving us a 0. And we divide everything by the following. We have the square root here. With the length here, we therefore have minus 1 squared plus 1 squared, like so. And we have the square root as well of 1 squared plus 1 squared. And this means that we have cosine theta, which is 1 divided by the square root of 2, the square root of 2, like so. And this means that we have cosine theta equals 1/2, and therefore the angle theta equals arc cosine of 1/2. And what is arc cosine of 1/2? Right, we remember that arc cosine of 1/2 is equivalent to pi over 3 radians. Pi over 3 radians, which equals exactly 60 degrees. And we have solved this particular problem step by step. Any comment, remark, or question on this one, Adrahang? Any different suggestion to this?
No.
Okay, thank you so much. We move to the next one. Right, so, right, in the next case, we are looking at even more problems that remain very important for us to take into account. Given the vectors A and B, find the following. So we have what we call the vector cross products. So we're going to actually look at the fact that we have been given the vector A with the components 2, -1, and 0, and we simultaneously have the fact that the vector B is given by the following, right? So the vector B is 0, 1, 2, like so, right? And with this mentioned, we're able to obtain the vector cross product of A and B, and this is the ith component, the jth component, and the kth component. And we proceed to position the vector A as follows. Now, 2, -1, 0. The vector B has 0, 1, and 2, like so. And we are able to obtain the following facts, meaning that at this point, we have vector I. And now, if you block the first column and the first row, then we have this. And therefore, if you multiply this by that, you get -2 minus 0. And now here, this is exactly 4 minus 0, right, which is exactly 2. Right, so now this is good. This is good. And then it means, therefore, now the actual vector cross product of A and B can be seen as follows. So, I mean, this one you can write as -2 unit vector I minus 4 unit vector J to unit vector K, right? Meaning at this point, we have that this is -2 minus 4, 2. Right, and we have exactly this. We have exactly that. And so now, this is what we get. This is exactly what we're able to get. Right. Any different suggestion to this there? Arkahan? Anything new, different?
No.
Okay, that's fine. That's okay. We still have the vector A with the components 2, -1, 0. And we still have the vector B with the components 0, 1, 2. And we want to find the B cross A, vector B cross vector A, I, J, K. What is B? 0, 1, 2. A, 2 -1, 0. Let's compute this, meaning we have the unit vector I, and if we block this column and this row, you multiply this with that, you get exactly a 0 plus 2. Minus J, you cross this and that, and this would give us exactly -4 plus K, and this gives us exactly a -2. And this gives us exactly 2I plus 4J minus 2K, and therefore it means that we have vector B cross the vector K, which equals 2, 4, -2, like so. Now, okay, we know this, but simultaneously, what is A cross B? Because now B cross A is 2, 4, -2. What is A cross B? A cross B is -2, -4, 2. -2, -4, 2. A cross B is -2, -4, 2. Now, if you compare B cross A, right, so we're able to see, therefore, that B cross A is a little bit, it's a little bit different. It is different indeed. Right, it is certainly different. In what way is it different? Right, in what way is it different? You really can see that the vector B cross A is a vector that is in the opposite direction. In the opposite direction, because the B cross A has 2, 4, -2. But if you multiply this vector by a negative, you then have -2, -4, and 2, and therefore which is the vector A cross B. And therefore, these two vectors can be compared, but you really can see that B cross A is the negative of A cross B, and this is actually what happens there. Let me actually give a small activity. Right, what do you think B cross B is? Right, given that the vector B is 0, 1, 2, what is B cross B? Right, you have 1 minute to try this one. As soon as you're done, please let us know. Right, we're doing B cross B. 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 Right. B cross B. Right. B cross B. Right. How far, Atlehong?
Oh, I'm done.
What answer are you getting?
I got 6, -4, 2.
Okay, yeah, you got. I'm gonna do like this, right? So, and if I do it that way, what are you getting? Did you say 6?
Yes,
Then what else?
-4.
Then -4. And what else?
2.
2. That's fine. Remember that we're practicing here. And then I'm going to ask you another question after this. But there's something I can say here. In general, in mathematics, if you have, let's check first the answer, and then I'm going to share the theoretical aspect of this. So which is I, J, K. What is B? B is 0, 1, 2. Okay, it's B, B, and also it's also what? 0, 1, 2. Meaning we have the I. If this is the I, what is 1 by 2? 2. Minus 1 by 2. Okay, minus J, because the signs alternate. And if the signs alternate, then what they give us is that this one is a positive, negative, plus associated signs. So that in the end, then this is the J, and you block this and that. And if you block this and that, you have actually 0, because this by that is 0 minus this by that, which is 0. K. K. Right. Now looking at the K, unit vector K, we block the first row in the first column, and this is giving us 0 by 1, which is 0 minus 0. What is 2 minus 2, Atlehong?
0.
Is 0. Never mind that. I'm just teasing you. Okay, I'm just teasing you sometimes. I like teasing students. Okay, now in the end, B cross B is 0, 0, 0, meaning B cross B is actually 0, 0, 0, like so. Of course, in the middle, you can think it's minus 0, but it is 0. Okay, it is 0. And so as a consequence, we are able to then say that B cross B equals 0, 0, 0. Any question, any suggestion, any remark?
No.
No. Okay, I want to mention something. So we have a principle like a law. And the law says if you cross any vector V, you cross it with itself, the result is 0. The result is 0. So if you cross a vector V with itself, finding the vector cross product, the result is what? Is the 0 vector. The result is the 0 vector. So now it's something you need to take into account, but I mean, think of this very seriously. We move to the next point. We move to the next point. And we're able to achieve the following. Right. I'm going to give you 2.2.2 to try. Unit vector A dot this one, and if vector A is 2 minus 1, 0, and vector B is 0, 1, 2. I'm going to give you this one to try for some good 2 minutes. When you're done, please let us know, and then we will do it together.
Okay.
Thank you. You forgive me because I'm going to throw some questions at you just to see, so that you don't slip, so that you do not slip and you stay awake. Okay, but I know you're awake, but yeah, it helps. Let me know when you're done, please.
Okay.
All right, thanks. All right, thanks. Right, you let us know when you're done so that we can go on and try the problems. So that you can go on and try the problems. So that we can go on and try the problems. So yeah, just let us know as soon as you're done, that you're done, and then we shall do these together.
Okay.
Okay. But we can do these together. Right, please let us know when you're done. So that we can know when you're done. So that we can know when you're done. So that we can know when you're done. Okay. Right, so that we can know when you're done. Right, here, please let us know when you're done. And then I know you're tired. I know you're exhausted this afternoon. Right, so I'm trying to stretch your mind. You know, it's fair. I stretch your mind. So yeah. Right,
I'm done.
you're done. Okay, also, what answer did you get? There at Lahang?
Good. -4.
You got -4. Uh-huh.
No.
Is it only -4, right?
No.
Okay,
4
what
and
else?
0. 4 and
Yeah.
0.
Is it 4 and 0?
Wait.
Please come again.
Oh, sorry. The answer is 0.
Did you get 0?
Yeah.
Okay, so the 4 is not there.
No.
Okay, that's fine. That's fine. We are practicing, remember? So don't feel guilty, okay? Please do not feel guilty. So first things first, we shall do the vector cross product. First, we shall do A cross B. I, J, K. 2 minus 1, 0. 0, 1, 2. A cross B. And then now, if you block this and that, you'd have -1 times 2 minus this, which is actually -2. Okay, because the signs always alternate. We have a plus here, a minus here, and then a plus there. Okay, so with that, therefore, we have a -j. Okay, so having a -j blocking the middle row and the first, rather the middle column, and the first row, we'd have 2 by 2, giving us a 4 minus 0. We have a k, right? So column K, and we multiply this by that, getting exactly 2 plus 0. A cross B. Right, so at this point, what we're getting here is minus 2I minus 4J plus 2K. Okay, we got this before, but yeah, we're just practicing here. So that we actually, therefore, are able to say the vector cross product of A and B is actually minus 2, minus 4, and 2, like so. Okay, pay attention and take a look at these here. Right, pay attention and take a look at these here. Right, so whatever we're getting right now is what we got before. We got A cross B to be actually this in the previous question. Right, as proof, A cross B was minus 2. A cross B was minus 2 minus 4, 2. Minus 2 minus 4, 2. Minus 2 minus 4, 2. Then you'd have the A cross B. And what is vector A? Right, vector A is 2 minus 1, 0. Dot vector A cross B, which is minus 2 minus 4, 2. Like so. Multiplying the first component by the first gives us a minus 4. Minus 1 times minus 4 gives us actually a 4. And 0 with the 2 gives us a 0. And the result is 0. Wow. Congratulations to you. I'm excited that you gave the correct answer. You gave the correct answer. So this is very, very impressive. Okay, so yeah, we're excited. We're excited. Any comment, any question, any remark, anything to add or remove? At long?
No.
Nothing. Thank you so much. We move to the next point. Move to the next point. I want to mention something that is important here about these vectors. About these vectors. Okay, now, here is a vector. Okay, you have a situation where you have points. You have points 1, 3, 1, and give them names. Let's give them names. Right, so you have points P and 1, 3, 2. Another point Q, 0, minus 1, 4. Find the equation of the line joining the 2 points. Joining the 2 points. Find the equation of the line joining the 2 points. What do you think of this one? And what is the answer to this? If you can't see, let me know. Okay, points P and Q are given. 1, 3, 2, Q has the coordinate 0, minus 1, 4. Find the equation of the line joining the 2 points. What do you think of this? What do you think of this? What do you think of this? Right. What do you think of this? What do you think of this? Let me know when you're done, please. Then we shall discuss it together. Points P and Q. P has the coordinate 1, 3, 2. Q has the coordinate 0, minus 1, 4. Find the equation of the line joining the 2 points. Find the equation of the line joining the 2 points. What do you think of this particular question here? What do you think of this particular question here? Let me know, please, when you're done.
Okay.
Okay, thank you. Remember, we're just practicing, so we're just trying to have a conversation and see what we can learn, if anything to add, subtract, if anything new to learn, and that is the objective of this discussion. It's about learning. It's about impartation, and this is what the discussion is about. Right, and this is very, very important. Right. This is very, very important. This is very, very important. This is very, very important. This is extremely important. Right, how far? I keep reminding you. You forgive me? I keep reminding you. You forgive me? Right, so you forgive me because we keep reminding you. Right. Keep reminding you. Right, how far?
Almost.
All right. All right. You need to remember the given information. We want to find the equation of the line joining the 2 points. Given the point P, remember that these things we're just discussing, and we do the corrections of each of the questions. So, and now if I just give you, these are like points. They are not vectors, they're points. They're points. Right. Right, so please let us know when you're done. So we're good. Right, we're good. Right, we're good. Right, we're good. Right, please remind me when you're done, please, because I don't want you to fall asleep when I'm still expecting the answer. Remember, we're just practicing here. I'm just throwing the questions at you. I'm just throwing the questions at you. It is therefore our hope that obviously you are processing the questions. And I'm gonna throw like tons of questions. The aim of these questions is not to threaten you. The aim of these questions is to unlock the potential in you, to make you realize something, you know, because I'm a coach. I'm like a soccer coach. You know what the coach does? The coach looks at the player and decides, okay, the player must do this, the player must do that, and the player must run like this. You know, it's part of the coaching. If the coach does not let the player run during the match, even if you can bring the best coach in the world, you know, if the player does not get on the pitch and try and kick the ball and, you know, and run a little bit, oh, right out. Because now you see, these soccer players need to get on the field of play, right? So yeah. Right, so yeah. So we're just discussing the things, and then we shall look at the planes. We shall look at the planes. Right, we shall look at the planes. Right. Right. Shall look at the planes. We shall look at the planes. Right. How far? I remind you. Right.
Almost there.
All right. Right, so it is. All right, so yeah, we good. And then now, obviously, just update me in terms of what happens, you know, in terms of what happens.
Okay.
Yeah.
But,
Yes, please, you're done. What answer did you get?
x squared plus y squared plus z squared is equal to 5.
X squared plus y squared plus z squared is 5, right? That's fine. That's fine. So, but now the couple of things you need to take into account as you deal with this here. You know, what we then do is the following. To find the equation of a line, you need a vector, because you need to look at the fact that you're dealing with the z-axis, the y-axis, and then the what? The x-axis. So now the point P here is a point such that x is 1, y is 3, and then now you have this point here. You have this point here, and then z is 2, right? Meaning you'd have sort of this point there. Right, so in the end then, the point being described is as follows. All right, so now in the end, then what do we have in here? So we need to say, what is the point that is being described? Okay, the point being described is this one here. It's that point. And this is the point P with the components 1, 3, 2. So then, what then we need to actually find is, so we have this point P, and then now you'd have another point Q, where X, Y, and Z are the components. X is 0, Y is -1. And then now Z is a 4. So something like that. So if you are to look at these points, and then they find the equation of the line joining the 2 points. So if you look at this one as the initial point and this point Q with the component 0, -1, 4, like this. So you are able to realize that at this point, whatever you have having is that you can have PQ, which is the final point 0, -1, 4, which is the final point minus the initial point. And this means that we have PQ equals, so the final point here, it's 0, -1, it's a -1, and this becomes a -4, and this becomes 2. So that in the end then, we have the vector that is obtained, and this vector is the vector as a result of the 2 points that are being joined, P and Q. And this will be sort of the vector parallel to the line. And then now to find the vector equation of the line, we proceed as follows. So we then say that the vector equation of the line, therefore, is obtained as follows. So you then say X, Y, Z. It's the initial point. So the vector equation of the line is going to be one of the points. The point P plus T times PQ. Some of these things you might have never done in your life, you know. Some of these things you might never done, but I'm trying to make sure that, because this is how much you can go, quite. You like performing a lot of operations. So now, this means you'd have, what is the vector P? Right. We have the following. So what is the vector P? The vector P is 1, 3, 2. T, what is the vector PQ? It's -1, -4, 2. Right, so obviously if this is the equation of the line joining the 2 points, right, and this line here being not a line segment, being just a line, and therefore T becomes an element of R. So this becomes the equation of the line. And then now, we then have the following. We then have the following. So which means that you would have X at T, which is 1 minus T. Y at T is 3 minus 4T. Z at T, which is 2 plus 2T, where T itself is the real number. So you can write these kinds of equations. These kinds of equations are called the parametric. Parametric what? Parametric equations. Parametric equations. Right. So we continue. Right. Now, these are the things that are key. Right, so now, what then, this is exactly what needs to be done. And this is the answer to the question. This you might have never seen, but I'm just asking the kinds of questions that sometimes can be, unusual questions, so that you can actually be in a position to respond very well. To respond very well. And to learn a thing or two. Do you have a question here? Any remark?
No.
Okay, that's fine. I'm going to be throwing questions at you. And I'm going to be throwing questions at you. Right. And the questions will be as follows. The questions will be as follows. So yeah, the couple of things that we do. Right, a couple of things that needs to be done. All right, so now obviously you need to make sure that you follow and you understand exactly what is happening here. What about if we want you to be able to find the equation of the plane? The equation of the plane. So now let us ask another question here. Okay, some of these things you might have never seen because I realized that the course might be a bit too basic, this one, and then the other things might be kept for your second year course, but you need to have the chance to engage with them. It's not going to be a lot of the kinds of things that we will ask you that you have never possibly seen in your whole life, and so we have the following. Okay, now if you look at the A cross B, look at the A cross B. Right, so now at the end, we then say, find the equation. Okay, find the equation. Find the equation of the plane. Let me write properly here. Okay, some of the things you might have never seen, but this is the objective of learning here. Find the equation of the plane. Find the equation of the plane. Right, the equation of the plane joining or containing, or the equation of the plane that contains the equation of the plane that contains the vectors A and B. What do you think of this one? Find the equation of the plane that contains the vectors A and B. What do you think of this question? Right. We continue. We continue. All right, I'm giving it 2 minutes, please. Find the equation of the plane because these two vectors,
Okay.
because I'm just throwing some of the questions at you that are not usual. Take note of them. Repeat the questions during your own time because some of the questions they're not like a lot of them. So, but now you can repeat the questions, and I'm going to give you some exercises to try so that you can actually get in shape. But also, take note of the kinds of things that you need to learn. Take note of the kinds of things that you need to learn. Right. Take note of the kinds of things that you need to learn. All right. So this is what exactly we have. Right. Right. Yeah, right. We continue. Right. All right. So we good. We good. We good. Right. We good. We good. We good. We good. We good. Right. We good. Right. We good. We good. 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 Right. So please let us know. I know that some of them maybe have never seen in your life because I'm just forming this question. They can ask, find the equation of a plane. But now you're like, okay, how do I even start dealing with the plane? You know? Because now we have lines and planes, but now there's more we can do with this. So there's more we can do with this. Right, there's more we can do with this. Right, so
Okay, I think the equation is
okay, you think the equation is the following. Yep, let me just write it down because I want us to compare. We're going to compare the answers. Okay, what do you think the equation is?
negative 2i.
Okay, you think it is like minus 2i. Is it like minus 2, like minus 1, minus 2? Okay,
Minus 4j
minus 4j,
plus 2k.
plus 2k. Okay, I get you. I get you. Right, so it's fine, but we're going to put this answer in a block. We're going to save the answer. We're going to just keep the answer there. We're going to just keep the answer. Right. So as we keep this answer, then we're able to then say, we then need to find the equation of the plane that contains the vectors. The equation of the plane that contains the vectors. So in the end, then, we're able to then say, what is the equation of the plane that contains the vectors? Right. Right. So in the end, then, we want to be able to find the equation of it. So to find the equation of the plane, that contains the two vectors, you need to note that you need to find a normal to the plane. And this gives us a normal to the plane. Right, given a plane which is a two-dimensional setup, you can be able to find a normal to the plane, which is a vector perpendicular to the plane. Right, so right. So we continue. We continue. So now if you have vector A cross B would be I, JK, 2 minus 1, 0, 0, 1, 2. Okay, we've already done this one. So now if you multiply this minus 1 times 2, and you subtract this, it's a minus 2. Then you have the J. Multiply this by that, subtract, you have a 4. We have the K. You multiply this by that, gives us exactly 2. Meaning, therefore, you'd have, okay, yeah, we can first multiply out everything. So we then have minus 2i minus 4j plus 2k, which is minus that, that. Okay, so this is A cross B, and we're getting that answer. But now think with me. Think with me. Because if this is A cross B, then what exactly do you need to do here to find the equation of the plane? Right, so in other words, this has allowed us to find something we call the normal to the plane, or just a normal to the plane. So this is, if this is a plane, two-dimensional structure, then a vector perpendicular to the surface is called the normal to the plane. Right, so continue. Right, so we continue. We continue. We continue and then say we have the following. So now to find the equation of a plane, we therefore need two things. We need a normal to the plane, which we have already got. And we also need an arbitrary point on the plane. An arbitrary point on the plane, so that we can then say, let XYZ be a point on the plane. Be a point on the plane. So that in the end, then we have X, Y, Z, X, Y, Z as a point on the plane minus one of the vectors. Minus one of the vectors. Right, so if this is the case, and one of the vectors would be 2 minus 1, 0. It doesn't really matter which one, anyone. And you dot that with, okay, some of the things you might have never seen, it's okay, you're learning them, So you need an extra point, an arbitrary point on the plane, and now you subtract from the point the vector A. You dot this with the normal, and which is minus that, and the result is what? Is 0, like so. It's 0, like so. It's 0, like so. All right. So now you subtract this component wise, x minus 2 So obviously, if we subtract this, then you get a vector. Right, so if you subtract this, then you get a vector, which is x minus 2, y plus 1, z minus 0, okay, continue. So we continue. Right. So yeah, we have x minus 2, then we have the y plus 1, and then z minus 0. You dot that with minus 2, minus 4, 2. Okay, because it's the dot product, then the result is 0. So because this vector, we take this A as a vector on the plane, and if subtract it with this, then it produces a vector on the plane, and therefore, if you take the dot product with a normal, it would be therefore that the result is going to be 0. Meaning, so you multiply this with that, which is minus 2x minus 2, component-wise multiplication. Component-wise multiplication. Y plus 1. Z equals 0. 2x plus 4. Minus 4y minus 4. Plus 2z equals 0. Plus 2z equals 0. Okay, so get this equation. And this equation is minus 2x minus 4y plus 2z equals. Okay, so yeah, this and that gives us a 0. So we have exactly this here. And which is minus 2x minus 4y plus 2z. So then this means if you have minus 2x minus 4y plus 2z equals 0, you divide through by 2 or by negative 2. Getting it, if you divide through by negative 2, then you have an x. A 2y minus z equals 0. Okay, so your okay. Okay, continue. Right, we continue. So this becomes the answer. What is the equation of the plane? It is this one. It is exactly this one. So the equation of the plane is actually like x plus 2y minus z equals 0. This becomes the equation of the plane, the green one. Okay, you might have never seen this in your life, but take note of this because we can just do those extra things that you need to know in mathematics when dealing with vectors. But once again, we have not yet like come across this in your exercises. Okay, these are like problems from your school. Okay, they are like problems from your school, so we're good. Now let's look at number 3. Given the points P, hey, it's like I knew there were points. The truth is, I didn't know. Okay, I just gave the points P and Q before, like in the previous question here, like P and Q. I was just giving this from my head. But now I can see number 3. Given the points P with coordinates 3, 1, and 4, Q with the coordinates minus 2, minus 2, and 3. Find the distance between the point P and the XY plane. Can I give you like 1 minute to try this one and then we do it together?
Mhm.
Okay, yeah, because you'll forgive me if I just ask you something small to do. Okay, maybe let's do it together and then we shall do the next one. Okay, let's do this one together and then we shall do the next question. We shall do like 3.2. Okay, because, yeah, I want to make sure that you try, but sometimes it's not comfortable because I know the mind of a student. It's like the mind of a soccer player on the pitch. The body says don't run. The body says don't go to school, don't go to class, don't go to the church, don't go, don't do. That's how the body feels. The mind says go, but the body says I'm tired. And then you need to decide. Okay, so this is the sort of thing that happens. But now find the distance between the point P and the XY plane. Right, so now at this point, to find the distance between the point P and the XY plane in 3.1, we proceed as follows. Right, we are focusing on 3.1. We are focusing on 3.1, and this is what we are able to achieve as a consequence. As a consequence. Right, so if you look at the fact that you have here the z-axis, the y-axis, and then the x-axis. Okay, all these are positive, meaning you have a point somewhere there whose components are 3, 1, 4. This is the xy plane. This one here, it's the xy plane. So if you need to find the actual distance between the point and the xy plane, this is like, what is the shortest distance between What is the shortest distance between a line and a point? Have you ever been asked that question? You have seen that question before. If we look at a point, at a line, and then now we're asking the question, what is the shortest distance between a point and a line? So yeah, you can be able to answer that question. You can be able to answer that question. So you then say, so, okay, so now the shortest distance is the perpendicular distance. So it is the same thing here, because if this is the point, then the shortest distance is the what? Is the perpendicular distance. Is the perpendicular distance. That is the shortest distance. So now at this point, you would have the coordinates of a point that is there. What are the coordinates of the point? X is going to be 3, Y is going to be 1, but Z is 0. So that in the end, then you can call this one here point R. So right now you are finding the distance between P and R. Between P and R. Okay, if you're finding the distance between P and R, then we're able to then say the distance PR is the same as the following. So it is x2 minus x1 squared. It is y2 minus y1 squared. It is z2 minus z1 squared. Meaning that now if we have the PR, right, so you'd have the PR. And then this one is PR, x2, y2, z2. What is x2? 3 minus x1, it is 3. You square that. y2, it's a 1 minus 1. You square that. z2 is 0 minus 4. So we have this. Okay, 3 minus 3 gives us a 0. 1 minus 1 gives us a 0. And we're only left with minus 4, which is square. And the square of minus 4 is a 16. The square root of 16 is 4 units. And we're then able to say, hence the distance. Right, hence the distance between point P and XY plane. It says between point P and XY plane. What is this distance? Right, an XY plane is 4 units. It's 4 units. It's 4 units. So, right. Any question here, Atlehan? Any question on this one? Because then you're going to try the next one. The next one is yours. So you need to make sure you understand because we're going to ask you the next one. Right. I'm going to ask you the next one.
What is the coordinate of R?
Please come again.
What is the coordinate of R where there is Z0?
That's a good question. Why is the coordinate of R where there is Z0? Because we are dealing with what? We're dealing with the XY plane, and in the XY plane, Z is 0. Because there's no Z. Z is only when you go above like this. So on the XY plane, there's no Z, so Z is 0 there. It's only X that exists, and the X, according to the point P of the coordinates, because P takes the X and the Y component from the XY plane. And now it takes them here because X is 3 and Y is what? Y is 1. So it means, therefore, the point P takes the X and the Y components from what? It takes the X and the Y components from the XY plane. Right. And now on the XY plane, we're able to see, therefore, that X and Y are both naught. They're both naught. Okay, if they're both 0, then we can deal with the fact that the R component, the Z component is 0. Any point that is on the XY plane has Z0. What are the coordinates of the point here? On the x-axis. Okay, on the point here, X is going to be 3, Y is 0, Z is 0. If you're dealing with this, what is the coordinate of the point on the y-axis? Component of the point, whenever there is a 1, okay, because there's like Y is 1, okay? So the Y that is 1 at the point P, it's Y that is coming from the y-axis, okay? So on the y-axis, then Y is what? Y is 1 according to the point P. But now, on the y-axis, the coordinates of the point P are X is 0, 1, 0. But Z is always 0 anyway. But we're defining the coordinates of the point on the x-axis. Like if you say, like there's a number 2 here, there's a number 3 here. What are the coordinates of the point? This one. 3 and 0. What are the coordinates of this point? 0 and 2. Okay? So on the y-axis, then X is 0. Why? Why is X 0 on the y-axis? Because we just write 0 and 2. But at the origin, both is 0. Both X and Y are 0. But on the x-axis, X is 3 and Y is 0. You understand? Okay, yeah. So think about that. Because now we're asking you 3.2. Find the distance between the point P and the x-axis. And then we shall go on. Please try that one.
Okay.
Try 3.2. If you can't see, please let me know. If you can't see, please let me know. If you can't see, please let me know. So we continue. We continue. We continue. We continue. Right. And then we shall do it together. But yeah, you're trying 3.2. Find the distance. 3.2 says, find the distance between the point P and the x-axis. Right. Right. Okay. All right. All right. All right.
I think I have the answer.
Please come again.
I think I have the answer.
What do you think the answer is? That's okay.
Root of 17.
Okay, you think the answer is the square root of 17.
Yes.
Let's take a look. You're right. You're right. So I want to find the distance between the point P and the x-axis. So we're going to just visualize a little bit and see what is happening here. Z-axis, y-axis, x-axis. And we have here the point P, because all the coordinate the components are positive, so we have 314. Right? So, but you want to find the actual distance between the point P and the x-axis. But you need to remember that the x-axis, therefore, the point P takes its components from here. It takes x equals 3 there and y equals 4, so that you have the point P sitting with its base here. But now, at this point, if you want to, therefore, be in a position to then say, what is the distance between the point P and the x-axis? You're actually dealing with this particular distance here, such that you are having the shortest distance possible, because this is the distance between a point and a line, and therefore we want the shortest possible distance. And that would mean at this point, you are dealing with the fact that this point must be directly above, for instance, the point 3 there, as a matter of fact. So that now you'd actually therefore have a situation where here you have a point R, right? You have a point R, and this point R has the coordinates x is 3, 0, 0, PQ, rather PR. Okay, let us find PR. So that then we have here the square root of x2 minus x1 squared, y2 minus y1 squared, z2 minus z1 squared, PR. So we have x1, y1, z1, x2, y2, z2. What is x2? y2, z2, Right, this is 0, and then it's 1 plus 16. And 1 plus 16 is actually the square root of 17 units. It's actually the square root of 17 units. Right, it is the square root of 17 units. Right, so you're right, you're on point. You are most certainly on point. Right, let us find the vector PQ. Let me see what you're going to do here. I'm just going to give you a split second to try 3.3. Okay, the point P has the coordinates 3, 1, and 4. The point Q has the coordinates -2, -2, and 3. But you want to find the vector PQ or QP. How do you find the vector QP? How do you find the vector QP? Right. How do you find the vector QP? So we continue. Let us know, please, when you're done.
Okay.
Yep. Right. Right. Please let us know when you're done.
Okay.
All right. So here we can ask two questions. Okay, they asked one, but you can say find the vector QP. After that, we can find the vector PQ also. Right, so in other words, we can decide to add question 3.4, which was not part of this, where we then say find the vector QP like this. Find the vector QP like that. Find the vector QP, I mean PQ, because the QP is the same. All right. Anyway, I'm saying, yeah, you try that one, please let us know when you're done with it. And then we'll mark. How far?
Okay, I'm done.
What answer did you get? I'm going to write it down. Okay, I'm just doing this for practice purposes, just to engage your senses. Yeah, what answer did you get so that you compare?
-11.
-11.
17.
17.
And 4.
And 4. Okay, now let's look at this and think together. But we want to find a vector PQ, or rather first QP. So we're going to say the vector QP is the same as, so we're starting from Q and we're ending at P. So Q is our initial point, from Q to P, from Q to P. So we are moving from Q to P, right? And so according to this, QP. So this one is our final point. And this one becomes our what? Our initial point. So that we can then say, from Q to P, we have our final point. Our final point is the point P with the coordinates 314. Our initial point -2, -2, 3. So right now, the final point would be the following, right? From Q to P, right? So we are dealing with the final point, which is 3, 1, 4 minus the initial point. Right, so we have the final point, which is exactly 3, 1, 4 minus the initial point, and the initial point is the point Q, which is -2, -2, 3, like so. Okay, this gives us exactly what we need. This gives us exactly what we need. So these are the things we need. So the Q, therefore, has the coordinates -2, -2, 3. That is the point Q. So right now, if we're dealing exactly the QP, we're gonna have a vector. 3 minus into -2 gives us a 5. 1 minus into -2 gives us a 3. 4 minus 3 gives us a 1, like this. 5, 3, 1. 5, 3, 1. Okay. Let us find together right now PQ, please. Let us find PQ. I'm giving you a split second. Okay. Some people like speaking of what you call a split second. Yar?
I got -5.
Yes. Okay, let's see. You got -5, yeah?
-3.
-3.
-1.
-1. Okay, you're on point. Because now we're moving from P to Q. Q is our final point. So you're going to say Q, our final point, which is -2, -2, 3, because that's Q is our final point, minus P, our initial point. P, our initial point is 314. P, our initial point is 314. Subtracting this here would be -2 minus 3, which is a -5. -2 minus 1 is a -3. 3 minus 4 is a -1, like so. And it's exactly what you got. So yeah, well done, well done, well done there. So I'm glad that you now understand what to do. We move to the next question. To the next question. Right. Given the vectors A, which has the component 1, 1, 4, B with the components So with vector A with the components 1, 1, 4, and B with the components 0, 2, minus 3, find the unit vector in the direction of vector A. Find the unit vector in the direction of vector A. So what then do we do here? Okay, I'm giving a split second to try this one, then we're gonna do it together. There's no train smash. Find a unit vector in the direction of vector A. We're gonna do it together, but yeah, I'm just giving you first so that I see what you think about these questions. Because, right. Right. Right, so right, and continue. We continue. We continue. Right. Right.
I got the answer.
What did you get as the answer?
I got 1 over root 51,
Yes.
1 over root 51, then 4 over root 51.
That's fine. That's fine. No worries. We're practicing. I just test you from time to time, okay, to see what you think, because you're the student here. Right. Now, given the vectors A and B, given the vectors, vector A with which is the component 1, 1, 4, and the vector B with the components 0, 2, minus 3, find the unit vector in the direction of vector A. So now that would be the vector A divided by its length. And therefore, the vector A is 114 divided by the square root of 1 squared, 4 squared. 114. Okay, which is 1 plus 1 plus 16, because 4 squared is 16, but 1 squared is 1 squared is 1. Which is 114 square root of 18. Which is 1 over the square root of 18. 1 over the square root of 18. 4 over the square root of 18. Like this. Like this. So in the end, then this is what we're getting. This is what we're getting. And then this means hence. So, which is 18 here, 1 over the square root of 18, and this is 4 over the square root of 18, and therefore this is exactly what we have here. Hence, A divided by that is 1 over the square root of 18, 1 over the square root of 18, and then you have 4 over the square root of 18 there as the components. Any question?
No.
No question. That's okay, we're practicing. So now, in other words, what is a unit vector? To find a unit vector in the direction of a given vector, you take that vector and you divide by the length of the same vector. Divide by the length of the same vector, and the length of the vector A, just the length of this one, which is exactly that. So yeah, that's good. Right. That's good. That's so good. What 1.2 says, find a vector of length 5 in the opposite direction to A. So we continue. I want to know what you think about 4.2, and then we shall do it together. Find a vector of length 5 in the opposite direction to A. Okay, so we're good. We're good. We're good. It's so good. Right. Right. We continue. We continue. We continue. We continue. Right, please let us know how far.
Okay.
All right. Right.
I hope you are good. I hope you are doing well. This is
Right.
from Polymath Academy, tutoring maths and physics. Okay, for those who still want to join the online classes, still available. Check more information on my profile, and you can text me so we can talk. And we have also still have the that special of of 150, of 141 subjects, 140 for one subject. Then if you are going to do both maths and physics, then you pay 240. This is valid until tomorrow.
Right. How far? We are practicing, remember? It's not a war. You know, it's not a wrestling match. We're not wrestling, but we're simply practicing. So you'll forgive me then, because sometimes I just throw the questions at you, and the objective is not to cause harm or injury. The objective is to ensure that all goes well. The objective is to ensure that all goes well. Right. So we continue. Right. So we continue. Right. How far? Yep. You coming all right? And remember, I'm not expecting you to get 100% in these things. I'm just asking, you know? I just want to know what you think about them. Right. So, yeah, we're good. Right. Okay, some of the questions are going to cause pain to you. Some of these will cause pain to you.
I think I got the answer.
Okay, what answers did you get? The Orthogonal?
-1/5.
Okay, let's check that one. So you think you got the answer. We check together. So you think you got the answer. You got -1/5. Is it like this?
Yeah. Yes. -1/5. Then -4/5.
-4/5. Is it like this?
No. It's
Okay, how is it?
-5.
It's -1/5.
Then comma.
Then comma.
-1/5.
-1/5. Another
Then
comma.
-4/5.
Then -4/5. Okay, we're good. Now let's check this and see. Let's check this and see if it is correct. Okay, so we're practicing, remember, so there's no train smash, but we're trying to see what mistakes you can make and you can correct them. Right, given the vectors A and B, so we're given the vector A with the components 1, 1, 4. The vector B, 0, 2, -3. Zero, 2, -3. Then find a vector of length 5 in the opposite direction. Right, in the opposite direction to A. So a vector that is of length 5 in the opposite direction to A. So now a vector in the opposite direction to A would be vector -A, but it is actually a vector of length 5. So you multiply it by 5, but also because it is a vector in the direction of A, right? So you can always take any vector, in this case, a unit vector. Meaning we have minus the vector A, which is 114, divided by the length of the vector A, which is exactly 114. And then you have a 5 here. Right, and if you multiply through, you get a minus 5 minus 20 divided by, now you have here the length of this particular vector. Okay, so we mean the length of this vector. Right, so the length of this vector can be seen as what? Right, so it is the length of the 114, and become the square root of 1 squared, 4 squared. And therefore, this is the same as so minus 5, 20 divided by the square root of 18. Like so. And with this mentioned, we good. Minus 5 out of the square root of 18. Okay, minus 5 out of the square root of 18. 20 out of the square root of 18. 20 out of the square root of 18. So, which is minus 5 out of the square root of 18. Minus 5 out of the square root of 18. And okay, so yeah, this is minus 20. So this is like an 20. So this is actually minus 20 over the square root of 18. In other words, it means the vector that is required is the following. Right, so it means that for the vector that is required, which is minus vector A by 5 of length 5 divided by the length of A is actually the same as the vector with the components minus 5 out of the square root of 18, minus 5 out of the square root of 18, and minus 20. Right. Okay, we continue. So this would be actually then minus 20 over the square root of, right, minus 20 over the square root of 18. Minus 20 over the square root of 18. Right, so, and obviously this becomes sort of the result. This becomes the answer to the question. Minus 5 out of the square root of 18, minus 5 out of the square root of 18, and minus 20 over the square root of 18 square root, yeah? Right, so, and this is the answer. Any question, anything to add, anything to remove, subtract, any different opinion?
No.
Or nothing, eh? Right, once again, these things we are engaging from time to time. I know very well that by asking, I want to make sure that you like get to think of this, even for the shortest amount of time. It makes a big, big difference, a huge difference this makes. Right, question 5. We have already done a question like this, but yeah, we're practicing. Question 5 goes on to say, find the angle. Find the angle between the vectors A with the components 0, 1, minus 1, and B with the components minus 1, and 0. Right. I'm giving you 1 minute to find the angle between the vectors A and B. When you're done, please let us know.
Okay.
All right. I know it is something similar. Right. I know it is something similar. Right. We continue. We continue. When you're done, please let us know. I know we did something similar. Right. Right, we continue. Right. Right.
I got the answer.
What did you get, Atong?
I
Just
got
curious.
pi
Uh-huh.
over 3.
Okay, that's fine. You think you got pi out of 3, correct? Right, you say you got pi out of 3. Is that what you're saying?
Yes.
Okay, that's fine. Remember, we're practicing here. But there's a formula we use that says the cosine of the angle is A dot B divided by the length of A, the length of B. Which means you'd have cosine theta 0, 1, minus 1, minus 1, minus 1, 0. Okay, this is the vector A, vector B, then divide by the length of the individual vectors. Right, and therefore, if you have the length of A is the square root of 0 squared, 1 squared, minus 1 squared. The square root of minus 1 squared, 0 squared. Which means that cosine theta 0, 0, minus 1, 0. Okay. Square root of 2, square root of 2. Which means that cosine theta is minus 1 over 2. Okay, minus 1 out of 2. And what is this? What is this? So you're dealing with a situation where the cosine is negative. Right, so in which quadrant? So in other words, in view of the cast diagram, there are 2 quadrants in which the cosine is negative, meaning you can put your triangle here or you can put your triangle there.
Mm.
Right, because all of them are positive here and the cosine is positive here by the cast rule. Okay, so now it means therefore we have 2 possible angles. Can be an angle that is here, an angle that's there. Okay, if you look at this one, which is soccer tower, right, and then you're dealing with the cosine, which is adjacent of hypotenuse. And this one is going to be the square root of 3 by Pythagoras theorem. Because if you use x squared plus y squared is r squared, and the r being 2 squared, the x being minus 1 squared, and the y squared. So y squared is 4 minus 1, giving us a 3, which means y is plus or minus the square root of 3. Meaning you can get this one, or you can get this one here, like that. Meaning that in principle, then obviously, if you want to find these, then the angle here would have to be the angle that sits there, or is one of the angles. But now, to get these angles, you need to first get what you call a reference angle. It helps. It makes a huge difference. You can jump it if you like. But now, there's something called the reference angle. The reference angle would be arc cosine of the positive, which is pi out of 3. Which means, therefore, theta would be pi minus pi out of 3. Okay, to get this one. Like pi minus pi out of 3. Okay, because pi minus pi out of 3 is like 180 minus 60, which takes us to the second quadrant. And the second quadrant, the cosine is negative there. And this, if you take the LCD 3, then it's going to be like, out of 1 here, 3 divided by 1 is 3. By 3, it's going to be exactly 3 pi minus pi. And the result is actually 2 pi out of 3. So it's one of the angles. But obviously, you can think about the other possible angles that you can also get are in view of this. But now this is one of the angles that gives us an angle in the second quadrant. Right, so it's something you can obviously think about. But the angle here, so the pi out of 2 pi out of 3 is one angle, and this is a possible angle. It's certainly a possible angle. But again, I mean, you can investigate other possible angles here. Right, in which this is the case, because also you can look at what happens here. ZYX, where the x is 0, y is 1, and z is minus 1. Right, so and now if you look at the fact that z is minus 1, you're going down here to minus 1, and then y is 1. Here, y is 1, and z is minus 1. Right, and if that is the case, then that sort of describes a point. Simultaneously, this here you have that x is what? You have that x is actually 0. Okay, I want to look at this carefully. Okay, we're looking at a situation where y is 1, and you have that your z is actually a negative 1, but your x is 0, meaning that we are, if x is 0, it means that we are in the yz plane. YZ plane. And we're actually dealing with a situation where y is 1, and simultaneously we're dealing with a situation where z itself is minus 1, a point that is somewhere there in the zy plane. So, and this would be like the vector A, and then the vector B would be where x is minus 1, x is minus 1. And then simultaneously you have y is minus 1. Okay? X is minus 1. Y is minus 1. The point that is somewhere there. Right, and the point that is somewhere there then would give us vector B. Right, and therefore, if these obviously are sort of the two vectors you have, and you are therefore interested in the angle between those two vectors, if these two vectors are vectors that sit, are vectors in standard position, like that. Right, so vectors in standard position are vectors that are, stem from the origin. Right, so looking at that, then you're able to see as a consequence that there are possible angles you can get, and you can actually get theta equals to pi of 3. And because this one here is it's an angle that is what? It's an angle that is obtuse. Obtuse. Right now, if these particular vectors, now, so this angle here is like 2 pi that, which is 120 degrees. Right, so it is 120 degrees, so that is sort of the angle you're getting. Yes, please, yeah. All right, that's fine. What is your destination again, please? Confirm your destination. All right, okay, I will do now. Okay. Okay, let me request. Right, so, yeah, so this becomes an obtuse angle. That becomes an obtuse angle there. So, yeah, this is certainly very much enough. Very much enough. But once again, you're dealing with the possibility of angles, but now the angle 2 pi over 3 is an acceptable angle there. So it is very much okay to actually, deal with that angle there. Any question, any remark, any comment, and then we move to the next question. But once again, using the reference angle, another student, is important to mention in passing that another student can get 180 degrees plus that. Okay, please, if you do, what angle would you get if you're gonna do pi plus pi of 3, because pi of 3 is our reference angle? What angle would you get?
4 pi over 3.
Maybe 4 pi over 3. 4 pi over 3. So now the angle 4 pi over 3 would be a very interesting one to also look at. But you need to think of whether this angle is possible or not. But it is an angle that sits in the what? It's an angle that sits in the, so now that will be 4 pi of 3. To an angle that sits in the what? In the third quadrant, right? It sits in the third quadrant. So it's something that you need to think about. So then obviously you need to therefore continue analyzing this. Okay, so you would have also, that is a possibility that you can examine and try to think of whether it makes a kind of sense that is required there, as a matter of fact. Maybe we can throw in one more question. Right. The angle between two unit vectors A and B is this one. Find the dot product. Okay, I'm giving you like 2 minutes. And then when you're done, please let us know, and then we can see what to do. Okay.
Okay.
Right, good. Good. Right. Good. We're good. Right. So we continue. Please let us know when you're done.
Okay.
All right. Please let us know when you're done. Right, please let us know when you're done. Right. Please let us know when you're done. Okay, please let us know when you're done. Okay, I'm just teaching you some of the questions. But as soon as you're done, please let us know, and then we can see what to do. Then we can see what to do. Right, we continue. We continue.
I got 1/√2.
You got 1 over the square root of 2. Okay, let us check together if this makes sense. Let us check together if this makes the kind of sense that is required. So now, the couple of things obviously you need to take into account here. It is the fact that you are dealing with the fact that the cosine of theta is A dot B divided by the length of vector A, the length of vector B. And now we are saying the cosine of pi over 4 equals A dot B divided by the length is 1 by 1, because these are unit vectors. If they are unit vectors, it means the length is 1. So the length of vector A is 1, the length of vector B is 1. Why? Because these are unit vectors. With that mentioned, the cosine of pi over 4 is 1 out of the square root of 2 using a calculator, which is A dot B. So yeah, you're right there. So that is the answer. That is the answer. So obviously the question was, what is A dot B? So now this means we hence have that A dot B is 1 out of the square root of 2. It's 1 out of the square root of 2. Right, you got this one right, correct. Right, we must thank you for joining us. It was awesome having this discussion, and then we shall meet again, yeah, tomorrow. You let me know if you're free tomorrow, and then we can do tomorrow and Saturday. Okay, if you're not, you still let me know. But yeah, we can do something like that, like tomorrow and Saturday. But if you're busy, you still let us know. Yeah, it was awesome having a discussion with you because you had a chance to just try 1 or 2 questions, which I'll send you the recording in the next couple of minutes. Yeah, awesome having a discussion with you. Thank you so much for joining us. Have yourself a good evening and good night.
Good night.
Good night.